Right, let's get started. For this BTLO replay, we will solve a lab named test. This is a medium digital forensics box from Blue Team Labs Online. And our task is to perform analysis and report basic profiling of the evidence. And by that, we will use Sleuthkit, EWF tools, John, SQLite3, and grep because this is a Linux box. And for the scenario, as a short assignment, you are given a disk image without any context to perform analysis and report the basic profiling of evidence. You need to prove that this is your day. Evidence and sample files were kept on desktop. Right, let's get started. So we have this helpful files. Okay, text. This seems familiar. I think this is a text file that is used for password cracking, which we will be using later on. And also for the evidence file, we have this .eo-e01 extension. This is our disk image. So to start our lab, let's first verify this one. So we remember that we have tools in this box called EWF. EWF or expert witness file. So we'll navigate to the desktop and the evidence. So we will try to EWF info our this image. So here we have several details or information. We have the acquiree information, the case number, the notes, the system date of acquisition date, also the serial number, EWF information, and many more. So as a digital forensic examiner, before we start to mount this file, we make sure that it's our acquisition has gone successful. So we can do that by the command or a tool part of it, EWF verify, point it to the .e01. This might take a while. So we have finished verifying our evidence file. So for this task, for this lab, it might take a while. It might take minutes of your lab time, but in the details, so we need to prove that this is our first day as digital forensic examiner. So as good practice, it's really good to verify the evidence file. It's a good practice as an examiner, especially if you're on your first day. So yeah, so it will take a few minutes to complete, but at least you have this MD5 hash calculated, which can be used for documentation for your case, right? So let's start answering question number 1. So we have what is the name of the tool used to create this image? Okay, I think we have encountered the answer for this one when we execute the EWF info tool. Let's run it again. EWF info and the compromise. So in the acquired information, we have the case number, we have the examiner name, Sherlock, We have the acquisition date and also the operating system used. Okay. And software used is Guy Major. Okay. And the version. So if you are new to this field and you don't know what this one, you can perform basic search, Google it, and yeah, and we'll perform that. So this tool, it seems this is our answer for question number one. So we've done uh Guy Mager, anything. This is a free forensic imager for media acquisition. So yeah, can confirm this is our answer. Let's submit that one. Guy Mager. Yep, expected. So next with question number two, what is the manufacturer name of the USB used to collect evidence? Name should be as per the evidence. So for this one, I think we need to mount this image to our system so that we can inspect it using sleuthkit. And we've came across this useful resources. So we have to perform this commands here just to mount the evidence file into the disk. So we'll do it right away. So we'll open terminal first. So our first task is to create the directory. So we'll create it under the location mount. Use the name EWF file exists. Okay. Seems that I've already created the file. Uh, I've already performed. Okay. So okay, let me explain first. So since what we I have already created the location and also the mounting itself, save me time. So let me explain what I've done so far. So we've created a EWF directory in the mount location. Then we've assigned the EWF directory to our account, which is Ubuntu, this one. And also we've used EWF mount pointing to our case file into the EWF directory which we've previously created. Why we have this EWF1 file. And also, if we go to the EWF directory, we use file, we have the DOS MBR boot sector, which which means that we have successfully mounted our the .e01 case file. Okay, let's start answering question number two. What is the manufacturer name of the USB used to collect evidence? Name should be as per evidence. So since we have successfully mounted our evidence file, our next step is to list the file and directories of this image. So by that, we will use this one, FLS, a tool. So we'll do that by FLS-R. Oh wait. So before we do that, so let's check the partition table of the mounted evidence file. So we'll use the MMLS pointing to our mounted evidence file. So so we are interested in this Linux partition since it has it, the s- starting sector is 2048. It ends to like this number. So we have this length over here. So we assume that this is our partition of interest because we have a large file system here, which we assume this is a 12 gigabyte. Comparing to other partitions, which is just the swap table, yeah, other stuffs. So we are interested with the Linux 83. So we're gonna use this one to with FLS dash O dash R P dash 8. Then our file D. I think we'll get. So here using FLS, we have successfully mounted. We have successfully viewed the directories under the evidence files. So we will use this throughout this video, explore the directories and the files inside the evidence file, evidence or this image. So to answer your question, I think the USB, the manufacturer name of the USB used to collect evidence, I think we will need to perform some research about it to understand where is it located in their system. Yeah. So in Linux, file access from a USB device are not tracked by specific log file by default. So, however, if you need if we need to find the name of the USB device, the files that were accessed from it, we will use the combination of system, logs, command history, and mounted file system information. Our first um, location of choice is the syslog under the var log directory. We'll use yeah. So definitely, if you are tasked to find any artifacts related to USB devices connected to a system, especially in Linux, you will start with the log file because that's all. Um, because Linux done a great job logging all the changes in the system. P-O, which are offset 48, pointing to this image. Then grep log. Think. Yep, we have this ID. So in Linux, every file is treated similarly. In Linux they assign a ID for that so that we can use it to yeah. The Linux system they use this one to access the file itself. So for this one, we'll use the icat pointing to our offset. Then the number 7207. Then grep. Yeah, so I think we have found our answer for question number 2. What is the manufacturer name of the USB used to collect the evidence? USB. Sony, I think. I think this one, UFS. Try. Yep, we have found it. So our manufacturer name of the USB used to collect is UFS 2.1. So let's get back how we get the answer. First, we list all the the directories. Starting from the 2048 offset, which is the Linux partition. Then we list that since we are tasked to identify the USB manufacturer, we are tasked to look. We use the log files, the syslog files, and grab its ID. Use icat to view the file. icat offset pointing to the ID, the syslog ID, and using grep to filter out the results. Contains manufacturer. And yeah, we have found this one. So in question number 2, so what is this? What is the computer name? So let's proceed with question number 2. Number 3, what is the computer name? So in Linux systems, computer name are typically fetched through the etc hostname file. So let's try to find my fls s right fls dash t dash o 2048, then pointing to the. So it is found in the etc directory. So let's try 45 etc hostname here. This one. So we'll copy this one. Then we'll replace this. Oh, sorry. So for this one, we'll use icat 2048. So if it's not a directory, which is indicated here, for example, this one is a directory because it has a D initial. This one is not because this is a R. So if you are interested to viewing this file, you will use icat instead of FLS. So uh, yep, we got this Linux Warrior. Our answer. Type it. So for question number 4, what is the login password for the above user? We have here. We have this password and the shadow. Our next step is to save this text files. Save this file into a text file. So this is the content of the password file. You have this one, and the shadow is for this one. So our next step is to save this contents into the same text file. To do that by cat name it password warrior. So to answer the login password for the above user, we will resort to find the etc password and etc shadow, and we will view these files in order and save it into a one text file. We'll have our resources here. So the etc password and the shadow line should be in one text file. And we'll use the unshadow from John the Ripper, and we'll perform such actions. Have view this one, copy, then create a document, pass, okay, pass, save it. Then next one is the shadow file. This one, save it into a one text file, save it. Then we'll create another document. We'll name it shadow, and we'll paste the same file. Then on the we'll use a command named unshadow password, and the shadow to save it into crack.txt. In the crack.txt, we have it. We have here. Then our next step is to use John the Ripper to crack the password from this crack from this unshadow file, shadow password. So we'll use that to John word list home desktop full file. Then remember the rockq.txt. We'll point it into the crack.txt. This one. No password hashes crack left. Then we'll use John the Ripper to show us the crack password. So well, what we have here is this Linux 123. So John the Ripper, using the shadow and the password text files, we have successfully extracted the password or unshadowed the password, which will we assume this is our password, right? Not ended. Okay. Proceed with question number 1, 2, 5. Number 5, what is the name of the Linux distribution? Clear this up. Okay. Then our next task is to find the Linux distribution. So for this information, Linux stores it into the cat into the OS release, which we will sample the OS release. It's the same file. So the distribution, the same file. So we'll use this string or this location or this file to find it into our evidence file, so we can pull this the answer for this. Okay. Again, 28, then grep for, then grep press release, got the R. Yep. Have this one. I think this one. Let me find. Okay. Do it manually. Copy. Paste. Let's look for the OS release. OS release. This one. Yep. We'll use iCat. So, and file here. OS release. Fine. We've executed this command here. Same command without the first front slash. So we'll use this file icat -o. Yep, I think we have found it. I think this is, what is the name of the distribution? We have found it from this OS release file. This one. I think we have found our answer. Copy. Type. Perfect. Read right. So what is the start offset of the Linux partition? For this one, we already know, since if we run mmls against our evidence file, so this is our Linux partition. This is starting offset, the port 8. Correct. So what is the size of the Linux partition? Linux and swap partition in GB. Use fdisk. Okay. So to identify the sizes of a Linux and swap partitions in gigabyte, we'll resort to use an external tool. So we have identified this, that this is our Linux file, Linux partition. This is our swap file, our swap partition. So we'll grab this one, our length, and we'll paste it into these unit converters, which will convert block into a gigabyte. So this one, I think we have, for the Linux partitions, we have 6 gig. And for the Linux swap partition, let's copy and paste. I think we have 2, I guess. Let's try to submit. 6 and 2. Perfect. Right? So back to the next questions. What is the file system of the disk image? Okay. So the file system of the disk image will use a Linux tool named fstat, then pointing out to our partition, the Linux partition 2048, and the reference file. All that of results. And we have here system type. So guess that's our yep, perfect. So next question is what is the time zone of the machine? Okay. So the time zone is the we'll try to look at the etc file, etc directory. So back at fls dash r, then go to the etc directory, then look for use grep time. Okay, we have this one. So we'll use icat for this one. Icat-o 2048 Asia Kolkata. Use this. Next standard time. Try to submit. Nope. Wrong answer. We have identified that Asia Kolkata is India. So India standard time. Perfect. So next question is serial numbers of the USB connected to the PC, not the USB connected to collect the disk. Okay. For this one, I think we need to find the bar logs again. 48. One. Okay. Bar log and the 6 log factory. And are interested, we are tasked to find the USB, serial number of the USB. We'll use the syslog again, right? So I got -o 2048 7 07. Let's grep for USB. So where we are, has to find the serial number of the USB connected to the PC. Serial number, out. Okay. USB string, I think we have found it. This, yes. One, wait, right? So USB, so USB log files are typically found in the syslog under varlog, syslogs, under the var directory, log, and syslog file. Next, user opened a file from a USB that is connected to the machine. Meet the USB device name and the file name. Okay. Let's do a bit of research about this one. Get back. So we have found this interesting forum. So since we are tasked to find the uh, f- um, USB file that is open from a USB connected to machine, we assume that this is a recently opened file. So I think this one will browse at this certain location, the .local, to find if there are any entries about the file open from a USB share. Right? We'll browse again. ls o 8. Okay. Remember, it's in the home directory. So, okay, is that one? Again, remember we are in the local, right? Local. Okay, let's check. There. Okay. I think this one. You. iCat 48. Yep. So our task is this is the recent file access of our Linux Warrior account. So it's like a link file, I guess, Windows. So we are tasked to find the file from USB. It's connected to the machine. File. Yep. Yeah. I think we have found it because we are tasked to find a USB. Since it's a USB, it's a media file, and we have our user here. We assume this is the drive, the USB drive for the location, and this is our file, Linux fundamentals. Our format is USB name, the drive, then Linux fundamentals PDF. Sweet. So this is really interesting artifact in Linux systems. So it is found in the recently used XBEL under the .local directory in the home directory of our user. So back to the next question. So what is the name of the file download in the downloads folder? Okay. So the downloads folder. Really, we need to go to the home directory. Same thing again. Downloads. So we have this one. lfmusic.mp. What is next question is what is the antivirus product used by the user? So again, um, we assume that the user installed the antivirus product in this Linux system. So where do we find all the information about the installed products or the changes? For sure in the log directory. So we'll head back to the log files, var log. One, uh, log, no. I think we have found it. It's not in the log files. It's not on the syslog and logs. I think the antivirus has its own log file. So yes, we have found our antivirus. Because this check rootkit is a famous antivirus in Linux. It checks for a rootkits in the Linux systems. Yep. Check rootkit locally checks for signs of rootkit. Yes, that's the antivirus that we are looking for. It reads. Next question. According to the cron jobs, how often does the antivirus run? So cron jobs can be found in the etc directory. etc cron. Cron job is a scheduled task in Windows. Cron, cron, cron.d. Okay. Better to use. Yep. Manually. On. Check for the daily scheduled task. Here, let's view this file because this is our the antivirus. How often does the antivirus run? Use icat. View the file. So, audit the cron jobs. How often does the antivirus run? Okay. So since we have found the check rootkit scheduled in the cron.daily, we assume that's our answer. Cron.daily. Perfect. What is the file? Including extension that access via LibreOffice. So for this one, LibreOffice, the file including extension that access via Libre. Let's do some research about this one. We have found these resources from ask.libreoffice.org. I think this is their forum files or their forum. We have identified that it is the recent files is in the .config of the current user. We'll use that information to find if there are any file access via LibreOffice. So again, let's clear this up. Let's head to the user's home directory. Again, the .config where the LibreOffice stores recently accessed files. Then we have here LibreOffice. And then this one, registry modification.xcu file. So let's find registry rep. I guess we need to follow the four. Yeah. Look. So the registry modification.xcu file found is in that config, LibreOffice 4, and the user. We will follow S and user. Good. And this one. Try to read this one. Pepper file. Junk file. Presentation for you. .odp. What is the file? We are tasked file including the extension. I think this one. Copy. Read. Right. Ask Google search keywords. So we're in the user's home directory. So typically, the Firefox stores its browser history files or browser data into places that SQLite. So we'll use that. For that, with the /r for recursive, and let's grep for places SQLite. So here, found it. Check this file. At Need to download it. Paste it. Yep. Then connect it into another terminal. CD desktop. Then we'll use the dash dot help. Then for tables, since we are looking for the last Google search keywords, so let's use the select type. Our task to identify the last Google search keywords. Okay. I think we have found it. Linux Hero of 2021. So it's Linux Hero of 2021. Linux Hero of Beat. What is the name of the domain of the internet speed test website visited by the user? We will query all the URL from Moz places. Okay. URL of interest. Fast.com. Fine. What is fast.com? Okay, it's an internet speed test. I've found it. Meet our answer. What is the domain of the image sharing website visited by the user? Image sharing. We have Pinterest.com. Perfect. So has a user logged into other system using SSH? What are the credentials? So for this one, so the nature of logging into another system in using SSH is in Linux is typically using command line. So in a command line, every command that you have input here is log into a log file named bash history. So it is logged in a bash history file, which typically our point of our interest when it comes to um, evidence if there are SSH logs or login. So we'll resort to that. Then here we are in the our file. Let's head to the home directory. Go to the profile. The bash history. Okay. Question is, what has the user logged into another system using SSH? Yes, I guess this one. Format and IP. Submit this one. Perfect. So what is the last log on time to the identified user? One, we need to find the logs about it, about SSH. So again, go to the var log. Then we are interested in here, auth log, because this is where the authentication logs come in. Records any successful or unsuccessful log to the system. So we'll use that as our 218. Dot puts, filter it using grep pitch. Our task to identify the last lag on time to the identified remote system. So last lag on. I think this one. Log on time format. Day. It's 23 of May. Year 20. Time is 10:11. Perfect. Sweet. So yeah, that's I think that's it. So it's definitely a medium lab. So we have explored different um, artifacts in the Linux systems, especially um, the recent file access, log files. Also, we have learned how to mount this image, investigate it, and what are the points or the artifacts that can be useful to us investigators to identify or to basic profile our evidence file. So yeah, that's pretty much everything. Bye bye.